strength and momentum. Thank you, sir. Now I request Dr. S.M. Zogdan sir to felicitate Dr. D. Sir, Registrar SRP Union, Nanded. Thank you, sir. Now I request our keynote speaker, Dr. D.D. Pawar sir, to deliver their lecture on topic historical development and study of the universe. Okay, now I am going to handle this dais to Dr. Zogdan sir.
Dear participants, very good afternoon. In the second session, our beloved friend, Director of School of Mathematics and Sciences at our university, is going to deliver a lecture around historical development and study of the universe. After discussion, session is open for discussion. So I request all participants to enjoy lecture. Dr. D.D. Pawar sir and Dr. D.D. Pawar sir. Start the lecture.
That's why today I have chosen the new topic. Actually, my original topic of research is the theory of relativity and cosmological models. And I don't want to talk very technical topic in front of you because many of you are for this topic. That's why I have chosen my topic in such a way that little bit information about the scientists, about the mathematician, and starting from the era when our Indian mathematicians or mathematics was good, and now till today what is going on in this area of research. But because of time, actually total lecture is at least 1 hour because I have received the time of 12 to 1 hour time was there, allotted time. But now 2 o'clock is there. That's why because of time constraint, I don't want to talk in details of all those things. Actually, my lecture was organized in such a way that first I want to talk about the Indian knowledge system in terms of mathematics and astronomy. Which of them are working in this area from our ancient era to till. Second part was I want to talk about the foreign knowledge system. I guess just like as foreign knowledge system, which are the mathematician, astronomer work on the different topics, and finally what kind of research is going on under the direction of the study of the universe. But because of time, I don't want to talk all those contributions of different mathematicians and astronomers and what was our only within few words. If we observe the development of mathematics or science or research in our Indian culture, it started from the Nalanda University. All of you know about the Nalanda University. It was the first university in India. It was given the proper education in different fields. Nalanda University was founded by the Guptas dynasty, and it was flourished during the time of Harshavardhana. And again the other dynasties was there. There are different kinds of discoveries, different kinds of studies are there. Many Asian countries were attracted towards this university. Means many research scholars as well as students came from the different countries from Asia, China, Tibet, Sri Lanka, even though Korea. Many Korean or Chinese people studied in our Nalanda University at that time. And we can say that this is one of the golden era, 5th century to 12th century. Golden era of Indian mathematician as well as astronomer. The development of mathematics, first 5th to 12th century. It was very nice kind of research done by the Indian mathematician. After that, only one or two mathematicians were there till today. I think Madhava is there. After 15th century, Madhava had done little bit work in terms of mathematics as well as in terms of astronomy. But before that, many of you know the names of Aryabhatta as well as one of the crucial role of Aryabhatta in terms of astronomy. He was predicted. He was the first Indian mathematician or astronomer predicted about the Earth. Earth rotates on its axis. You know a little bit about the concept of universe, heliocentric universe and geocentric universe. Aristotle, before Aristotle, Plato, Ptolemy, all these are the philosophers. They were presented the idea of the universe is geocentric. Geocentric means Earth is at the center and all planets together with the sun, all celestial bodies moving towards the around the Earth. That was the concept before Christ, 300 years, presented by the Greek philosopher Aristotle. Actually, Aristotle was not any mathematician or any astronomer. He was the philosopher. But because of his thought, scientific thought, he has given some direction for the astronomer also. On the direction of Aristotle, the research is going along that direction, along the geocentric universe. And before Christ 300 years and after Christ 1500 years. See that more than 2000 years were there. No one can think about the new kind of centric, means geocentric to heliocentric. But some of the Indian mathematicians, Indian astronomers predicted about heliocentric model of the universe also. That Aryabhatta was the first. He was not completely, because the first idea proposed by the Aryabhatta is Earth rotates on its axis. Earth rotates on its axis, it means he is also followed the geocentric model, but not completely. He also opposed the idea of geocentric model through the second thing. He was 50-50. He was follower of 50% about the geocentric and about the heliocentric model of the universe. Heliocentric model means sun is at the center and all the planets together with the earth moving around the sun. Means before Christ 100 years to after Christ 500 years, Aryabhatta was the first Indian mathematician who was predicted about the heliocentric model. Second thing. Third thing is Aryabhatta introduced the trigonometric functions. Sine, cosine functions are there. Third thing is he was also predicted the earth circumference exactly. Also he was predicted the very accurate value of pi, 3.1416. Presently we know that it is very close to present value of the pi. Means at the time of era of 500 years, Aryabhatta predicted with the help of mathematical calculation. Also he has contributed a lot in terms of second one is the Brahmagupta. Actually Brahmagupta strongly criticized the work of Aryabhatta. Strongly criticized in terms of the idea of earth rotates on its axis. Aryabhatta opposes or refining the ideas of Aryabhatta. Brahmagupta wrote one book that is called as the Brahmasputa Siddhanta. In his book has given the ideas of planetary motions as well as eclipse as well as some astronomical calculations, and he has developed the new techniques for the astronomical observations. And these ideas are completely in oppose of Aryabhatta. After that, Bhaskara won in 7th century, third era of 7th century. Bhaskara, in line with the ideas of Aryabhatta, he was developed or refined or extended the ideas of Aryabhatta, and he was the follower of the idea of Earth rotates on its axis. Together with, he was also proposed the model of the universe, and also together with that sine and cosine function, trigonometric function, he has introduced the different kinds of trigonometric function, and that functions will be useful for the astronomical study. Many of you listen about different jokes in WhatsApp. What is the use of sine and cosine function? Ask to your mathematics teacher. All of you must know that all the astronomical developments, mathematical calculation done with the help of trigonometric function, sine as well as cosine function. That's why you are the mathematician, you must know. Hello. You must have the ideas about the trigonometric functions, what kind of applications are there, why Aryabhatta developed the trigonometric functions.
Because of the trigonometric function, we have developed the hyperbolic functions. And you know that what is the purpose of hyperbolic function? Because of the de Moivre's theorem, we have the relation between trigonometry to hyperbolic, hyperbolic to trigonometric. And because of such kind of relation, nowadays our fractional calculus, different kinds of derivatives, different kinds of integrals, fractional integrals, we are able to get the solution of different trigonometric function. Such kind of relations developed by the mathematicians. Because many fractional integrals, fractional derivatives are not directly calculated. It is not possible to have direct solution of such different kinds of function. But we have the standard formula in terms of power function. And because of power function, formula in fractional differential equations, that power function will express in terms of exponential function. And we know that the relation of exponential function with trigonometry as well as hyperbolic. That's the beauty behind the research, behind the trigonometric function they have developed by our mathematicians. Okay. Bhaskara 1 is the follower of Aryabhatta. That's why many of the things that were Aryabhatta presented, he was refined, he was developed, was extended. Next, Bhaskara 2nd. Bhaskara 2nd is use the ideas of both Aryabhatta as well as Brahmagupta, because they are in oppose of each other. Their concept about the astronomical development in the universe. Bhaskara has the combination of both. He has wrote the treatise that is called as the Siddhanta Shiromani. Siddhanta Shiromani having the 4 sections. 4 sections divided in 4 different parts. One is called as the Lilavati. Lilavati is for the arithmetic. Study for the arithmetic rules and regulation, decimal systems, different kinds of devotion were there. Second section is for Bijganita. Bijganita is purely for algebra. Third one is the Grahaganita. Grahaganita is purely developed for the astronomical objects, astronomical planets, celestial bodies. And fourth section is for the Gola Adhyaya. Gola Adhyaya, it is for the spherical trigonometry. With this 4 section, he has systematically given the ideas of 4 different parts of the mathematics. And with the help of that 4 different, also he has contributed in the differential calculus. He was the first proposed the idea of derivative. Proposed the idea of derivative predating of Newton as well as Leibniz. In the 11th or in the middle of 12th century.
In the middle of 12th century, we know that actual notations and development made by the Newton liberalized in about 17th century, at the end of 17th century. But before that, Basilekin has given the idea of derivatives in terms of planetary motion. This is also follower of Bhaskar II, and Madhava is a recent mathematician. Many of you already know his name because our university celebrated Madhava competition in district. Many of you have already given that competition also, Madhava competition. Madhava, after 12th century, he was one of the renowned mathematicians. Because of his work, many European mathematicians were influenced. His one infinite series, you know that Madhava lies infinite series in terms of pi. It was very famous infinite series, his work on that infinite series, and also he introduced some concepts of differentiation and integration in calculus. That's why in the middle of 14th century he was developed all those ideas. And also he was the founder of Kerala School of Astronomy and Mathematics. And Nilkantha is one of the members of same society. Means after the Madhava, Nilkantha has done lot of work in extension of Madhava's work. Just now I talked about the geocentric model and heliocentric model. What the problem there in the geocentric model of the universe? Because from before Christ, more than 350 years, many philosophers, astronomers, they were thinking about the geocentric model. Up to 15th century, what kind of problems they faced, and that's why, who was the first? Copernicus. Copernicus with the thoughts and was with the gap in universe are not orbiting to the earth, because the idea of geocentric model is all the planets, all the celestial bodies moving around the earth. And at that time, he under the telescope, he observed that Jupiter moons are not follow that idea. Again, second thing, Venus is rotating or orbiting around the sun. That's why he also sought the idea of heliocentric model of Copernicus. Third one is the Kepler. Many of you know about the Kepler's law. Before the Kepler, there is idea about the circular orbit of all the planets moving around the Earth in a circular orbit. And Kepler was the first, he was proved that in his Kepler's law, all planets moving in an elliptical orbit. Means because of these three mathematicians, astronomers, Copernicus, Galileo and Kepler, it was completely denied the idea of geocentric model. And after that, the research is going along the direction of heliocentric model. And nowadays, all of us know about the heliocentric model. Research is going on along the direction of sun is at the center, sun is revolving on its axis, and all planets moving around the sun in an elliptical orbit. This is the view of Galileo, as well as this is again the another topic. Today I don't want to introduce that topic because of time. Again, cosmology. Cosmology, we are doing our research in cosmology, cosmological models. What is meant by the cosmology? Cosmology is the branch of science which studies the universe as a whole. Cosmos means cosmo, and logy means it studies the universe or idea of the universe. Actually, there are two kind of philosophical thought as well as scientific thought is there. Many philosophers till today also, they believe that the universe is created by a God. Now it is, it was, it is, and it will be as it is because it is created by a God. There is no change in the universe. But many scientists, philosophers, and nowadays experimental evidences are there that universe is not created by a God. It is just a scientific process. You know the name of Stephen Hawking? Stephen Hawking predicted many things about the universe. History of time is there. Also he was talk about the universe, Big Bang. Also he was talk about the black hole. And so he predicted about the birth of the universe. And he finally, at his last conference, GRG conference was there. At that time he talked about the black hole. Previously he accepted the idea of everything is absorbed in a black hole, but nothing is emitted. Means he was talk about that conservation laws are failed there. But because you know that conservation law, the energy neither created nor destroyed. But at the black hole, no one can predict that what happened there. When everything is absorbed, after what happened about that bodies, about that different kinds of celestial bodies come near to the black hole, everything is absorbed, nothing is emitted. What happened at that time of their energies? If the conservation law is there, energy is not destroyed, means what happened about that bodies? Then finally, he taught that in his last lecture, I was wrong at that time. Conservation law is not failed there, but I don't know what kind of emission is there, but what kind of energy is there. Now I am not able to completely explain the idea of that kind of conservation law, but I now up to the conclusion that conservation is not failed in the black hole also. That's why many ideas of cosmologies from the ancient time, human being having the curiosity about the universe, different kinds of things. We on the five elements, Akash, water, Jal, आपले पांच तत्व आहेत ना, Agni, Jal, but Akash is not actual the fifth element of the universe. Actually, of the universe are water, fire, again matter, and fourth one is air. Fifth one Akash. Existence of Akash not, it is just a hypothetical concept. Ether like medium was there. Many of you listen about the ether medium. Ether medium काय होता? Just like our Indian philosophy, they were assumed that just like as sound waves, light waves also want some medium for its propagation. Light wave also want it some medium for its, because sound waves does not travel in an empty space. Just like that, assume that light wave also want some medium. That medium is ether like medium. And many mathematicians think about that. And Einstein, just before the Einstein, Michelson received the Nobel Prize for that idea. He denied the concept of ether-like medium. That's why our fifth element, Akash, is not actually exist. आपण म्हणतो ना आकाश आहे पण तो एक्झिस्टन्स मध्ये आकाश नाहीच आहे. It is just a part of universe. With this few word, I stop here. Otherwise, it will be all of you ready to listen. It will have minimum because Euclidean geometry, Riemannian geometry, what is the mathematics behind this research, then Newton is there, then Einstein is there, then many things are there. So I know that time is over. All of you are hungry. So with this few words, I stop here. Thank you. Actually, my talk is on theory of relativity and what is gravitation and all these things that I want to talk about today. But it's okay because of time. In the next conference, we will discuss about it. Thank you.
Session is open for discussion. If you have questions, you can ask or discuss with Dr. D.D. Pawar, sir.
We have heard this very hot topic today.
Yeah.
It is very huge kind of research opportunities in this area. Not only mathematician, but also physicists, but also statistician, because huge data is there. For the data analysis, there is a need of statistician, computer scientist, mathematician. Why there is a role of mathematics is there? Because they very tedious kind of mathematics is there. And no any physicist or no any astronomer able to find a solution of a complicated differential equation. That's why those are interested to do their research in this area. Nowadays also there is very tremendous kind of opportunities are there in this topic.
As you know, we have implemented a national education policy. And in that national education policy, we have two papers, which is Indian knowledge system and other is generic elective. Those students who want to wish teach or learn another subject from other faculty, which is the generic elective. So, Dr. D.D. Pawar sir have given us opportunity to discuss both these papers as Indian knowledge system and generic elective also. If Board of Studies given a generic elective in Marathi medium, I think more students will attract from other faculty to learn this generic elective because it's very interesting and a good topic. I think there is no any question from audience. So I declared here this session is over, and I am very thankful to the organizer to give us opportunity to hear and discuss with delegates. Thank you very much.
येतो की आपली काहीच करायची मानसिकता राहते. त्याच्यामुळे एक यंग एज मध्ये आपल्याला जॉबचे प्रॉब्लेम असतील, बाकीच्या प्रॉब्लेम असतील, बघा मागचा टाइम पासून तर आतापर्यंत जेवढे मॅथमॅटिशियन त्यांनी कधी म्हणजे रेमन जॉमेट्री डेव्हलप केली. ही डोंट नो मेनी ऍप्लिकेशन अबाउट हिज ओन काइंड ऑफ जॉमेट्री. त्याला माहिती नव्हतं की पुढे आइन्स्टाईन ती डेव्हलप केल्यामुळे पूर्ण रिसर्चची आयडिया कम्प्लिटली त्या डायरेक्शनने केली बिकॉज ऑफ ओनली रेमन इन जॉमेट्री. तोपर्यंत इक्लुडियन जॉमेट्री, आता इक्लुडियन जॉमेट्री, असे जे कन्सेप्ट असतात तुमचं इंटरेस्ट डेव्हलप करा. इंटरेस्ट डेव्हलप केल्याने कोणताही नाही तर दुसरं याचं काय पेपर वाचतो. इंटिग्रल ट्रान्सफॉर्मचे असे काही विद्यार्थी पाहिले. इंटिग्रल ट्रान्सफॉर्म आता नवीन इंटिग्रल ट्रान्सफॉर्मवर काम चालू आहे. त्याच्यावर नंबर ऑफ इंटिग्रल ट्रान्सफॉर्म आलेले आणि त्याला लाप्लास ट्रान्सफॉर्मची डेफिनेशन विचार काय माहिती, फोरियर ट्रान्सफॉर्म काय माहिती. आणि ज्याचा जन्म इंटिग्रल ट्रान्सफॉर्मचा जन्म ज्यांनी करून दिला, ज्याच्यावर एवढी सगळी डेव्हलपमेंट चालू तेच आपल्याला माहिती. आणि हे सगळे नंतरचे डेव्हलपमेंट म्हणजे आता काय नावाने ना त्याच्या नावाने असे वेगवेगळे जसे आपण फॅशनल वेगवेगळे अशा पद्धतीने होतात. आणि ज्यावेळेस कोणी काम करतं त्यावेळेस नक्की माहित नसतं की याचं काहीतरी बिकॉज वी आर ज्याला वाटेल तो त्याच घेईल, नाही तर नाही घेईल. बघा 4 डायमेन्शन पर्यंत गेलो. मॅथमॅटिक्स आपण n डायमेन्शन पर्यंत करतो. तो आहे काय नाहीये. म्हणजे अशा बऱ्याचशा आता हायपोथेटिकल कन्सेप्ट आणि तशा हायपोथेटिकल आम्हाला